Hello, I'm Ben. As you might be aware from my channel, most of the music I make is barely music at all in the traditional sense. It's just a series of very unpleasant sounds lazily sloshed together with a load of reverb on it, or occasionally just one very long boring sound. But what if I was to tell you it doesn't have to be like that? What if I was to tell you that I am capable of making melody on this equipment? You can actually make proper chromatically tuned Western style melodies using just the equipment I have in this studio. Or even less than this, you could just do it easier with the laptop on Ableton Live. But this is how you would go about sampling using tape in the style of the BBC Radiophonic Workshop, for example, who used this technique, along with loads of other stuff that's too clever for me, to make their catchy theme tunes and idents for commercial television in the 1960s. The basic premise is that you can take any tonal sound, or atonal sound really, and then change the speed of the recording when you play it back using a tape machine with a variable speed control. The one I have in the studio is the Revox A77, which uses quarter-inch magnetic recording tape and has been modified to allow a change of speed. What I can do is use an app on my phone or a oscillator if you have 40 like me to find the pitch of a note that I want to tune that sound to. So let's take an example. I'm going to blow across the top of this stinking milk bottle because it creates a very easy to work with tone with a nice soft attack and a reasonably long decay, giving me a good raw material to manipulate. It sounds like this. Glorious, but not very interesting at one pitch. So I'm going to record this to the Revox tape machine now, running the tape at 7.5 inches a second for reasons that will become important shortly. Excuse me. So now I have a recording of me blowing the bottle at one pitch on the tape, and I can now switch the tape machine into its variable speed mode so that I can change the pitch of the sound for my purposes. The first thing we need to do is get this running at the right pitch. You can use a piano or similar instrument if you've got them knocking about, or if you've got 40 accurate lab grade oscillators, you could also use those. I'm going to use an app on the phone because it's loads easier and I don't want to stand up. There's loads of free ones. Basically what you're looking for is an online tone generator. With this one I can put in the frequency I'd like to hear and it will play it. So for example, this is 440 Hertz, which is A. So it's just a sine wave, but it means I can get this in tune. So if we experiment with a few different settings, I can get this nicely lined up. I'll do A as an example, and then I'll go through and do all the other notes I need according to the plan, which I'll show you in a minute. So let's try a little bit slower. So that sounds pretty close. Yeah, great. What I'm now going to do is refer to this plan and work out what I need in terms of the number of A's. So this is a bit of a difficult one to follow, but I've made up my own stupid system here on this paper so that I can plan ahead. So here is the melody I'm going to make. We've got 1, 2, 3, 4 beats. I'm doing this at 120 BPM to make the maths a little bit easier, but you can do it at any speed if you're willing to do a bit of dividing. This also makes the measuring incredibly easy compared to some of the other BPMs available. But basically, I've got a letter there representing the note. The arrow is the length of the note following it. The X is blank or silence, so I'll insert a piece of blank white leader tape for that. And then on the right, what I've got is a list of the frequencies required to get the pitch shown on the left. So C is going to be 261.63 Hertz. I've also written down the length of tape I need to match the score on the left here. So, for example, C lasts for, what's that, 1 7/8 of an inch, is followed by 15/16 of an inch of white blank leader tape, and then the next note, which is the 4/16 of that beat, is going to be 15/16 of an inch as well. So I hope that makes sense. If not, give up now. It's just a bit fiddly. It's not very hard. It just takes forward planning. There's no advantage to doing this over just sampling it into Ableton apart from the fun aspect. I do quite enjoy this, and it's nice actually physically getting involved with the tape and screwing it up a bit, because you end up with some interesting happy accidents. Like I say, what I've got here is a shopping list of all the things I need. So I've written down in order the note, the pitch, the length. So the easiest thing to do is record all of the instances of, for example, C that you need, reel them off, cut them out, then go and tune the tape speed to the next note you need. In this case is G, record off however many you need of those, etc. Once you've got all your notes lined up and your blanks, you can then measure them, put them in order and stick them together. That's it. So let's have a go. This is obviously A, so we actually need two of these for the score, and they're only little ones, so we can just record a couple onto this second machine, which is also running at 7.5 inches a second. That's very important that we know what speed we're running at when we record it, because that affects the length of tape we need for a certain amount of time. So, just going to change on the patch bay so that this is taking signal in. This tape machine is now armed, and I've routed the variable speed tape machine into this. This means I can do a little bit of EQ to the sound or add effects before resampling it, but you can just record from one tape machine to another without all that, to be honest. I'm just extra fancy. I'm going to start the tape running, and I'm going to record my first A. Lovely. Now I've got to rewind the tape and do it again for the number of times I need that note. There we go. So that's 2. Next we're going to tune this to the C that we need. So this is obviously going to be lower. This is 261.63 Hertz. Just turn that off. Great, there we go, that's C. So let's slow this down a little bit. Bit lower, I think, a bit slower. Lower again, I think. Tiny bit faster. Tiny bit faster. I think that's near enough. So then we just repeat the process for the number of C's that we need for the piece. And we do that for all the notes, okay? So you end up with a table full of bits of tape eventually, and let me show you that from a different angle so you can see what I'm doing. I'll record a couple now, and then I'll just cut a few out as an example. I've actually carefully pre-prepared my loop because I accidentally didn't plug in the microphone last time, so I've got a lot of videos of me just cutting stuff up and not making any sense. So I'll give you a bit of a brief demonstration of a few notes, and you can just imagine me putting this horrible mess together in full. So let's record some of the C's we need. And then finally, let's just take a G. So that's 392, yes. There we go, near enough. There we go, that's probably enough, you get the idea. I'll show you a different angle now, and I'll show you how we find the attack of the sound. So that's the first initial part of the sound that we need for the sample. Okay, you are now me. This is what I have prepared, as I showed you earlier. I'm going to use this to build up the piece of music. It's just following process. It's a little bit tedious, but once you've got it planned out with your frequencies and blah 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 and lengths, it's not very difficult to do. It just takes a long time, and you have to be a little bit careful to make sure you stick the right bit of tape to the right other bit of tape. Let's have a listen to what's now on this tape. So what you'd end up with is basically a tape full of the different pitches you need. Now, referring back to the plan I made to help me compose this tune, or to realise this tune rather, I can see the order. I need these notes in and the length that I need. So, as I mentioned, the arrow shows the end of the note, and X denotes a silent moment, which will be made of white leader tape, which is blank. And yeah, that's how it works basically. So I'm going to go through with this Chinograph pencil and scrub the tape past the playhead while the machine isn't running in play mode, and listen for the start of the sound. I can then mark that off on the tape, and that's the way I'll be able to tell where my notes are, so I can cut them out with a razor blade. I've rewound the tape. Let's find the first note. To do this, I'm going to make sure the tape is in contact with the playhead. Because we're not in play mode, because we don't want to engage the capstan and drag the tape along at its own speed, I'm just going to bypass the mechanism that stops the tape from being in the presence of the tape head up against it when it's not being played. Now, you should be able to hear this as I manually move the tape past the playhead. We'll hear that boop. There it is. So now I'm going to manually rewind the tape and find the start of the sound by moving it forwards and backwards. So, there. Take the pencil, and on the non-magnetised side of the tape, I'm going to draw a line. That will allow us to find that moment again on the tape when we come to chop it up. It's really now a case of going through the whole tape and finding all the bits we need. etc. Because I know how many instances of each note are recorded off the vari-speed machine onto this tape, running at a fixed speed, I know, for example, that the first 3 or 2 are A, so I can just tick off when I've marked them with the white pencil on this pad, so I know I've got enough. Because I'm moving the tape by hand, it'll be at different speeds and pitches, so I wouldn't know just by playing it which note it was necessarily. That's why I keep count. So anyway, once you've done that for all the notes you need, rewind the tape and remove the reel. I'm now going to go through and use a splicing block to cut out the parts I need. And I'll just move the camera so you can see this in a bit more detail. Okay, so I've got the tape. The direction of travel is this way through the machine. That's very important to remember. I have a metal splicing block, and this allows me to put tape in this groove and use a razor blade to cut an accurate 45-degree angle through the tape. There is also one for sharp edits, but this can lead to a popping sound if you cut into a sound part way through. So it's best to use this very slight fade in, I find. Right, so on the non-magnetised side of the tape, I'm just going to keep pulling this out until I find the white line I left earlier. I'll just pop that back on there. And there it is. So now I can line up the white line, which you can see there, I hope. It's a bit dark, with the diagonal in the splicing block. Take a razor blade and make a clean cut through the tape. There we go. This can be discarded, but I don't actually throw it away because it's still valuable for making loops and things, so I pop it in a little box off camera and save that. Although you do get through a lot of tape with this technique, it's all reusable really. So I've cut the tape at the line. I'm going to mark this with the note, so it's an A, so I'll write that down. I'm also going to draw a line on to indicate the direction of travel in case I get mixed up or drop the pieces of tape or something. I've done that a few times, it's best just to write it on. So then I'm going to just cut it a fair distance from the start of the sound to make sure I've got a bit of tape to play with when I come to sticking it all together and cutting it to the right length. At this stage you don't have to be accurate, we're just getting a library of the notes. So let's cut that there and move this out of the way. Repeat this process all the way along the tape until we have a big pile of notes. Now got 10 pieces of tape, fairly random length, and a copy of all the notes I need, plus a bit of white leader tape for the gaps I need to insert for silent portions of this particular piece. So again, I refer to this and I look at my shopping and cutting list here, which is telling me the first one needs to be a C, and that's going to be 1 7/8 long, so you can see that's that, plus there's an X following it, so that's a 16th note of blank tape there. Okay, so I'm going to put that together now. So the first thing to do is take one of the C's I've got and measure out 1 7/8 of an inch using this ruler I have on the desk. So here we go, so 1 7/8 takes me to there. Then cut that. So that is that first note. It's not very long, very small actually. So it is very fiddly and you have to be patient. And the results are not worth it. But stick with me. This is what they had to do. So yeah, we've got our first bit there. That's followed by 15/16 of an inch of blank tape, so I'll use a small permanent marker to mark this white tape because obviously wax white pencil isn't going to cut it. So that's there. Excellent. I'll cut that using the splicing block again. And there we have it. I'm not sure how well you'll be able to see this, but there's a white piece of tape which is blank, and there's a piece of tape with our note on it. Direction of travel is that way, remember. So I'm going to join these together using a piece of this splicing tape, and I tend to use tweezers to position the tape. You want to make sure that you're not leaving a gap, but you're also not overlapping it, because if you get an overlap it can cause it to jam when it goes through the machine. A tiny gap is better than an overlap which runs like that. You could do it like this because that would obviously allow stuff to pass over it without getting caught, but like that it's just going to get caught on things. So there we go. That's how you do it. Two pieces of tape joined together. Now you move on to the next piece. So what does it say on here? It says it's a G of 15/16 of an inch in length. I've got that there and there. That's all marked out, easy to follow. I'm just going to find a G which I've marked out there and cut out 15/16 of that, making sure that I'm keeping it facing the right direction. So that would be there, and then I can just slice through the tape. Brilliant. And you guessed, it's just a case of sticking those pieces together using tweezers and splicing tape. And that is my life at the moment. So there we go. That's another little bit. You just have to keep doing this until you've completed the order and manifested the thing. I've actually prepared a full loop of this earlier when I'd forgotten to turn the microphone on, so I've had to do all this stuff again, but you know, good practice, isn't it? This is what I do. So this is what it sounds like. 3, 2, 1. So I hope it's clear how that correlates to this, which I pre-prepared. Now, you could in theory just make it up as you go along if you've got a brain for music. I don't. I'm not very good at music theory at all. That's why most of what I make is just a garbage fire of noise. But there you go, you can do proper melody with it. As I mentioned near the start of the video, the BBC Radiophonic Workshop were particularly good at this technique, composing a lot of theme tunes. For example, the Doctor Who theme tune, elements of it were made in this fashion. The bass line, dun 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 dun, was apparently a piece of wire stretched across some piece of rack mount equipment or something by Delia Derbyshire and Dick Mills and repitched. So yeah, you can do all sorts with this. I will now set fire to the entire room. I hope that was interesting. It's very niche, isn't it, and very nerdy, and there's that, like I said, there's just no reason to do this these days unless you really, really enjoy this sort of thing. I'm just doing it because I think it's fascinating that so much interesting music was made using such simple techniques. Really, it's incredible what you can build out of tiny pieces of tape. You can layer this up as well, and I think the sounds you get out of this and the randomness it introduces make for some interesting textures and more interesting music. Of course, you could do all that digitally, but I'm seeing this as a bit of a retirement home for unused and unloved equipment and a place to archive and keep old techniques going. So if you have any thoughts on this or any questions, please let me know. but I wish you the best of luck in doing this. I would encourage you to have a go. You can also do things with the loop once you've got it together, such as recording it to other bits of tape, so you can, sequence that loop over and over again, and you can change the speed down by half on most machines to get a lower octave. But yeah, I'm just fascinated by this particular technique. One of the hardest things I found about this technique was finding a tape machine capable of variable speed to the degree that's useful for this. The A77 behind me has been modified. It's not perfect, it's a little bit inaccurate, but it's good enough for me, The BBC Radiophonic Workshop used a machine which was very accurate by Levers Rich, who made a lot of broadcast quality tape machines. The idea was that it could sync to television signals, so it was able to do variable speed accurately, and they had it so you could chromatically tune it by twisting a dial. As far as I understand, the engineer would work with the composer. They'd kind of spit out the bits of tape at the right pitches in a nice row, and then they'd cut them up as they needed and compile the piece. But yeah, that was the most difficult part, finding a machine capable of true variable speed. Domestic machines tend to have either 2 or, if you're lucky, 3 speeds, namely 7.5 inches. The next one down, which is, I can't do the maths, 3 3/4 inches, and then 1 7/8 inches. So you can do octaves with that and still make really interesting stuff with it. But if you want to do, get a full chromatic scale out, you'd need to look for a machine that can do that. Quite a lot of pitch change to get anything useful musically out. But you can also apply this technique, of course, to any random sound you record. If you so wanted to, you could record all the notes from a sine generator and sequence them this way. I know that they did that at the Radiophonic Workshop sometimes. I think they had a keying unit, but I think for certain specific jobs they would do it this way. So yeah, you can sequence anything that you can record using this method. You don't have to change the pitch. But yeah, I hope you found this useful and interesting, or at least vaguely interesting. It's a real nerd thing, and there's no real benefit to doing this other than the fun and keeping something old going. But if you have any questions or queries, anything of that nature, please do get in touch. I'm more than happy to discuss anything to do with this with you. All right, go away.